that thought while I figure out what the heck I have done. This is not where I want to be. So let's get rid of that. I mean, this is what I wanted to show, but not like this. I want that on. And then I want to go and find where the heck I put that thingy and turn it off. Okay, there, we're back. Now, what that video was showing was this little thing right here. So there's an announcement from Intelitech, the place where I work. There's a link to a cool video I made, which was what you just briefly got an unfortunate introduction to without asking. But the sum of the announcements is the new EssentialC#.com website. So, for those who are interested, this is based upon the Essential C# book series by Mark Michaelis. Full disclosure, I was one of the technical editors for version 8 of the book, which I don't know where my physical copy went. It was sitting right here a moment ago. It's around here somewhere, I promise. Benjamin is in the chat. You can thank him for a lot of the work because a good chunk of this has been the Benjamin show. But this is now live and feedback is welcome. So one, if you have anything, there's a big feedback button up in the corner that'll take you to a GitHub repo to log an issue. Feel free to log away. The content in here is very similar to the print content, though it's been updated for a lot of the C#11 stuff. Now, I need to go back and double check. I think we got through all of the C#11 content. There's a question of, will it all be there? Like if you go through the release notes of what's new in C#11, you're going to find things in there that we just aren't likely to cover here. Because the idea here is this is the essential parts of C#, of what does somebody actually need to know to go from beginner to advanced, right? Think of it, entry-level person, senior C# developer-ish, at least in terms of the language, right? That's what's covered here. And there's going to be a lot of stuff that just doesn't get covered because subjectively, not essential for what it's worth. But feel free to throw feedback at us if there's something that seems to be non-essential or something that you think that there should be. If you find bugs and whatnot, let us know. We have put in way too many hours of work making this thing. The amount of code behind generating this site is a lot more than what I will get into, but it is pretty cool. And there's a lot of features that we have still in the works of what we would like to see coming. Interactive code listings, client-side compiler. You can think of this like what you see in the Microsoft Docs, where they're able to let you interact with the code samples and just run it right there. Full text search, records. This one I think is a lie. Yeah, this one's a lie. Benjamin, why is that still here? I thought I nuked it. Apparently my PR hasn't merged. I should go check my PR. But there are content updates and things coming as you go. And then what makes it really exciting for me is that you can just, hyperlink in at any of these headings so that, when people ask questions, I can now link them to something. Because the Microsoft Docs are good, but the Microsoft Docs often tell you the what of the language, not the why or the how, which is always bothering to me and frustrating and yucky and makes me feel bad. So, yeah, so at some point, I will go and make sure my PR goes through so that that ends up dying. The website for this, if you hit the feedback link, the website portion is actually open source. So if you find a bug that's related to the website itself, that's here. Now, I will warn you, the website, when I say the website project here, this does not contain any of the book contents inside of this repo. So this is we'll call it the shell of the website, and then we've got stuff that data drives and brings it all in. So if you run into something Yeah, Benjamin comments that it's open source and anyone can go and change that page, and I thought I had. Apparently not. Apparently not. I must have only talked about doing a PR, not actually doing it. If I get motivated, I'm going to circle back and go and fix that, because this is not content coming soon. This is content implemented. I think file scope namespaces are not done yet, though. Yeah. Yeah, file scope namespaces are not done yet. So those will be bits of content and things coming along as we get more and more added into it. So again, feedback very welcome. We know things are far from perfect. Every time you go through it, you find a few more things to go and change. Every time I go and look at it, I find little things that are just a little bit off, and then I have to go and fix them. So again, feedback very much welcome. Ooh. Benjamin, did you literally just open a PR? Hey, my PR did merge. So why didn't we ship this? See, I deleted them. Why do I still see the content? This isn't something that got mixed up in a somebody's force pushing over main. Hint, hint, nudge, nudge. But regardless, we'll get it merged. Okay, next announcement, and I don't know why that's there. Get rid of that. Okay, so earlier this week, and YouTube is all kinds of confused. Me and a colleague of mine, Artem, we did a lunch and learn, and the title of it was "Test It Right, Sleep Well at Night." A title that ChatGPT may have had a small hand in helping me come up with. But the idea was we were wanting to look into, the best way I think I can phrase it, the philosophy behind testing. Because teaching somebody the how and the what of writing tests, in my opinion, is kind of easy. I can do that. That's a technical problem. The harder part is getting people in the right mindset to do testing. That's a people problem, and I struggle with that a lot more. Because computers and code are things that I can control. People are not. So we tried to go through and have a fairly good discussion on TDD, and I'm going to summarize because I don't have an hour to rehash the whole thing. But no, better. I don't need to do this. I can do better than this. Stand by. Because when you give a talk, you have the slide deck. Booyah. Turns out I got my own slide deck. Okay, so I'm gonna just bust through the same slides that we were in here real quick, just to give a quick catch up. So the thing with TDD is most people get really focused on TDD being tied to like unit testing. Drop that out of your brain for a moment. Just ignore it. The important letter in TDD isn't the test portion of it, right? It's going for the D. Either test-driven development or test-driven design is almost another way of saying it, going with what is actually important. So the idea, and again, coming down to the very bottom, a tool for designing your code. So if you switch out of the idea that you're doing test or you're doing TDD for the idea of, oh, well, I have to write my tests first because that's what people tell me I'm supposed to do. I have to get all of this going. No. Throw that out. If you approach it from the idea that TDD is about getting the design of your code correct, it helps you think through the problem and think about what it is you're actually trying to do. I had posted out on Twitter before we did this talk asking people about, what stops you from writing tests early? Another MVP commented on there that, because I'm trying to remember how I phrased the question, something along, what stops you from writing tests early, or what would get you to write tests earlier, or what it was. And his comment was, as soon as he knows the shape of the code, he starts writing tests. Effectively, once he gets far enough in to understand the problem, right, is kind of what you can see. Because oftentimes people hear the idea of, well, you have to write your test first, and they get all hung up on this. How can I write tests? I don't even know what the code's supposed to look like yet. Okay. Get yourself to the point where you understand what it is you're trying to solve, because if you're able to start writing code, you must know something about what you're trying to accomplish. Otherwise, you're just spewing things at the compiler. But once you have an idea of what it's supposed to be doing, or what the shape of that solution is going to look like, you can start doing it. One of the other big things I would call out to people is this bottom question: is what is the source of truth? The implementation that you write, or the tests? Because there was a story I was told of a team where they did a lot of pair programming. They were very, very into test-driven development. And two members of that team sat down to work on a bit of code. One of them was a little bit newer to the team. And the senior, the person who'd been on the team a bit longer, kind of looked over the problematic area that they were going. He's like, you know what? Delete the whole file. And the newer person on the team was a little shocked at that. Like, you generally don't just delete the whole code. Like, rarely is that something that you do. But because they had tests that covered all of their requirements, the idea was, I can delete that entire class and rebuild the entire thing from the test, from the requirements of my test, to be able to go through and do it. So having that mental switch is the big one to do. Blah, 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 blah. Okay, so if you are interested in the blah, blah, blah portion of it, YouTube link to go watch the video on things, because I don't think I could completely do it justice without Artem. We'll do it here. The key thing here to note is switching your mentality to doing this is not a quick switch. It is not something that you just decide one day, I'm going to do this. This is like trying to get in shape, right? You don't just decide, I'm going to get in shape, go to the gym once and you're fine, right? That's not how it works. It takes effort. It takes practice. It takes training. The Artem's line, which I laughed at and loved and immediately put it in the slide deck, was treat it like a virus infecting your code base. Oh, cool. Thanks, Benjamin. And so understanding that actually switching to doing test-driven development will take practice and be a struggle. Like, that should be an expectation going into this. But it is 100% worth it. Okay, so getting all the way through that, there was a couple things. This is basically where we ended our talk, because one, we were out of time, and people were throwing things at me. Quite literally, watch the video. It's rather entertaining. So we did technically have one more slide on here that I wasn't able to get to, and I kind of knew going into it, we've got too much material. You're not getting to this last slide, which was fine. Like, we went into it with the idea that we weren't going to get here. But this is a little bit more of that practicality of how do you actually write a good test? Because I think at the end of our talk, a lot of people came out of that. There was one person who commented, I'm really excited to go write tests now. And I'm like, yes, yes, yes. That's what I want to hear, right? And I didn't want to necessarily leave people with the feel-good mentality and the rah-rah motivation and then just throw them to the wolves and let them go and hang themselves. So this is going to be a little bit more hands-on, grounded down on what to do. So writing good tests. One, give your test a good name, right? I usually like naming my tests with the idea of what's being tested, under what conditions is it being tested, and what's my expected outcome, right? The what, when, why, covering all of those. Some people like to have their test names be like longer sentences. I don't really care, honestly. What I told a colleague the other day is, as long as I can read your test name and understand what's being tested and what your expectations are of that test, I don't care how you format the name, right? But unit test names are expected to be somewhat long and verbose, and I shouldn't have used the word unit test. Test names are expected to be long and verbose. Right? The normal naming rules that you would apply to methods do not apply to tests. And they should give out that information. Right? Another good reason to name it this way, if you name it with enough verbosity, GitHub Copilot will eat it for breakfast and fill in the implementation for you. It is shockingly good at that. Shockingly good, especially after it starts seeing the pattern for your tests. Oh my word, Copilot's amazing. But circling back to the idea of that test-driven development and the idea that the point of it is to get you thinking about what you're actually doing. One of the big reasons why people advocate for writing tests first is because it tries to force you to think about what you're actually doing, what it is that you want. And more importantly, when you're writing tests, I see people write tests without thinking about what it is they actually need to test. Going back to the idea of, could you re-implement a class from your tests? If you imagine writing tests that cover all of your requirements, all of the things that have come in, that's what you need to write tests on. Because some people go, well, when do I know if I've written enough tests? Is it when my code coverage is 100%? No, that may not. You could have 100% code coverage and your code may not cover all the cases. Right? Code coverage only tells you what code was executed during a test, not that you've actually exercised all of it. Your code is tested when you've actually covered all of your requirements with tests. And then one of the things that shocked me was, I told the story in the talk as well. I was working on the system command line project, and we were discussing a property. It was something that was internal, and John, one of the leads on the project, made what seemed like audacious statement that this is dead code, we can delete it. And I had Visual Studio open. I'm like, wait, what? I'm looking at it in Visual Studio. I see references to this property. How can you say it's dead code? And he explained his reasoning to me later that there were, because he loves his NCrunch, absolutely loves it. There's lots of systems out there that will basically do that auto running of your tests and give you good indications of what codes execute by what tests, code coverage, live unit testing, whatever. But what he explained to me afterwards is that he had NCrunch open and he saw that property wasn't invoked by any of the tests. And since it wasn't invoked by any of the tests, and we have tests for all of our requirements, we can delete it. Now, there's going to be fallout from that because there were references to it. And so now we have to go and evaluate the code that was calling it and, see why it's there. But we can delete it without breaking any tests, which means the code isn't needed for any functional requirement that we have. And that was kind of a big brain shift for me of going, hang on, wait a minute. So code without a test is dead code. He referenced a book to me, and I wish I could remember the title. I went out and ordered a copy of it, and I can't remember what the title was. I think it was Working with Legacy Code, and I don't remember the author. But he had told me that in the book, the author made the claim that any code without tests is immediately legacy code. Again, another one of those mental shifts to consider. Okay, actually inside your test, a very common pattern is and one that I usually enjoy putting in my test is the arrange, act, assert pattern. You'll see people do AAA. The idea is that your test should functionally have 3 parts. I will sometimes literally put comments in my code for each of these of arrange. I set up all the everything I need for my test. Act, which ideally is a single line, because hopefully you're testing one thing. It may be multiple, but most of the time it's probably a single line. The act is the thing that you're testing, which if you imagine testing a method, right, it's the method you're calling. And then assert, right, all of my expectations of it. And just making sure that your test is organized in those 3 sections, and that you aren't necessarily mixing and matching. Now this gets a little weird, right? This is a guideline, not a hard and fast rule. And depending on what you're doing, it may actually not be the best pattern to follow. It is a great pattern for unit tests. It can be a good pattern for functional and integration tests. It is likely a bad pattern for UI tests. So just to, if you imagine the gradient of kind of your fast tests, of unit tests being on the left, all the way up to, your slow, monkey clicking test. That's kind of, arrange act assert works really well on the fast side, and its value tapers off the further you go along. Testing domain logic. Yeah, that's another good way of saying, especially if you've separated your code to where you have your domain logic in a different spot. It is often a good way of going through and doing that, because most of the time domain logic can be reasonably unit tested. But again, I'm going to try to do my best to not focus too much on the categorization of tests. People get really hung up on what's a unit test, what's a functional test, what's an integration test. And I think the better thing to do is actually to focus on what needs to be tested and at what level. Right? And making sure that you're focused on that rather than things like code coverage or, what type of test it is. Okay. This one I have been hammering my colleagues on repeatedly because they keep doing it and I keep telling them to knock it off. Avoid conditions and loops in your test. So they tend to sneak in a lot when people learn about data-driven tests, right? Rather than, having two tests, I can have one test and I can pass in values to it and do multiple things. And then people quickly run into the issue of, well, hang on, if I pass in a true instead of a false, I need to change some logic on what I'm doing. Like, these tests are pretty close, but I need an if statement here. And again, this is a guideline, not a hard and fast rule, but in general, I try to kill off all conditions. And the reason is you want your test to be fairly deterministic. And unless you're also evaluating like your code coverage on your tests as well, which generally the code coverage in your test project is somewhere close to high 90s, close to 100. Because occasionally there are things that you put in your test project that are designed to catch failures, and it's only executed in the case of a failure, right? So you may not hopefully have that case covered, but you still want to keep it. So it's 100% code coverage is never really a realistic expectation. But anytime you have a condition, it opens up the possibility for false positives or false negatives to creep into your code. There was one that I saw where there was a for loop that was written, but the termination condition, right? It was a standard for I equals 0, I less than, I think it was list.count or whatever it was in there, I plus plus. Standard for loop. The problem was the test was passing, but the code that was populating the list had been broken, and so the list was empty. And a loop, all loop constructs, at least in .NET, and I think this holds true for most languages, Java, C, loops are basically a conditional statement with some sort of jump to go along with them, right? That's the definition of a loop. They're just a fancy condition with a jump. So they have the same problem as if statements or any other condition. And again, conditional's a guideline, not a hard and fast rule. If perhaps you put in a condition, but you also put in, an assert on the else condition, that's mildly better. But there's also something to be said about the complexity of it, right? The other one that I saw is a colleague was trying to do a setup, was trying to put basically three things into a group. And so, for I equals 0, I less than 3, I plus plus, add the things into the group. And I made the comment, I'm like, we really should drop this loop. And he's like, why? Like, it's not going to be a problem. They're hard-coded values. I can guarantee it's going to run 3 times. And we went kind of back and forth on it a little bit. And I went through and I was like, I'm not saying you have to duplicate your code, the stuff that's inside your for loop 3 times. Let's pull that out into a method and let's just invoke it 3 times in a row. And in this case, invoking a method 3 times versus a for loop, like the for loop, open curly brace, line of code, closing brace, that's 4 lines of code. If we move it into a method inside of your test, that shrinks the number of lines in your test down by 1. You're now 3. You invoke method 3 times, and it's fairly straightforward to read. So, and oftentimes the other drawback with conditions and loops is it adds mental overhead just to process it. Even if it's simple, you may consider looking at refactoring those things away because they may not be needed. And again, the big risk factor is the false positive or false negatives creeping in, which can certainly happen in a lot of different cases. Okay, next one. Keep assertions focused on what is being tested. This one I see happen a lot. And I always, a lot of times when I see bad tests being written, specifically bad unit tests, a lot of it comes back to this very first point. Give it a good name, right? Every single one of your assertions should tie back to whatever you wrote in your test name. Some people go really dogmatic and say you should have a single assertion per test. And I kind of soften it a bit and go, yeah, a single logical assertion. You should only be asserting on the one thing that you're testing, right? Whether that takes 1 assert statement or 50, it doesn't really matter as long as it's focused on the one thing that's being tested, right? And coming all the way back around. So if you have a bunch of assertions and you're testing on various things, it's a little difficult to justify it. Let's see, question. A method that only delegates calling to another method. Do we need to test that? Because that'd be duplicating the unit test that's already been created for that delegated method. Great question. This one comes up quite a bit, and it's when I first saw it, it surprised me because I didn't think that it was a case that was that common. And then the very next day, I found myself writing those exact methods in the repo I was working in, and went, oh, well, I guess I need to eat my words on that one a little bit. So it is fairly common. So I guess it depends of do you need to test that? Because whether it needs to be tested, I think depends on the requirements of it. Oftentimes what I might do, and this is what, so I have a system that I was working on earlier today where I actually have several methods that are just like that. They delegate out to another class. What I ended up doing is I was like, I could test that the thing that they're delegating to, but at the end of the day, I don't actually care. What I really care about is, because the requirements for what I was doing, it was basically a retry logic for when authentication fails or times out, making sure the user's reprompted to log in, all of that jazz. And I was like, I could test the underlying class that's actually doing the calls to make sure that all the authentication pieces happen. I'm like, or I could test it at the top level and just verify that effectively because there's kind of this complicated state machine of, if the user's in this state, then they get this, and then they get prompted and all around. I'm like, really what I care about is does the state flow through that state machine properly and under the right conditions? And so one possible solution is don't test the inner class. Test it at that upper class and make sure that behaves. Because really what you're saying is that when you invoke that outer class, you expect the same behavior as that delegated method. Okay, great. Write a test, target the upper level thing, and then verify that you get the same return. Whether that method ended up delegating to some other class to do it or whether it did it itself, we don't really care. What we care about is, did it do the right thing? And so in one case, I went through and did it that way. Now that's not always a trivial thing to do, because sometimes you can't if you're delegating to another call, sometimes the thing that's being delegated to, it's intentionally been set up such that maybe it's set up with an interface, and we'll look at this in a minute, of it's intentionally being set there because you don't want to invoke it. Maybe it's hiding a third-party call behind an interface so that you can, maybe mock it or something. In those cases, I would, if it is important that delegated call get made, I would write the test. However, it will be very subjective about whether that's important or not. And that's going to go back to, is there a requirement that thing is satisfying by making that third party or making that delegated call? If the answer is no, it's an implementation detail, maybe it's a pretty low value test and not worth writing. Because there is a cost to some of this, but again, it's more about thinking through what are the requirements, and is that thing actually satisfying a requirement, or is it an implementation detail? Great question. Feel free to keep them coming. I actually love them. And then act and assert at the same level. So this is one that used to be a problem for some people I work with, and I don't think it's been as big of an issue recently. But when you're writing your test, and again, this is making the assertion that, or the idea that you're doing something similar to the arranged act assert pattern. So again, that pattern works best with faster tests, starts to fall apart as we move towards the right for slower tests like UI tests. But assuming we're in the fastish test range where that pattern makes sense, acting and asserting on the same level. So if you are acting on, class foo, don't necessarily do your assertions based upon implementation details. This is where I see things happen a lot, and it kind of goes back to your question earlier about, do you test the delegated method or not? Is oftentimes, especially when people are using mocks, I will see them go through and they'll do all their setups on their mocks, they'll run their test, and then they'll verify that all of the setups on their mocks were invoked. And that's not necessarily a bad thing, but you are effectively building a regression test that pins the internal implementation to invoking those mocks. And so the question should always be asked is, are you testing the behavior or the implementation? And that's not always a clear line, right? It's an easy sentence to say, but sometimes you get into code and it's kind of murky about what matters, right? The story from earlier about, could you delete your whole class and then rebuild it from your tests, kind of usually helps me think through, okay, if I were to delete this class, right, or if I were to just hand my test to somebody else on the team, could they implement the class correctly, right? Would I be confident that if I took my test and handed it to somebody else, that they would then give me back something that, if all of my tests pass, I would be comfortable with, right? Or are my tests so tightly coupled to some implementation detail that, I've asserted down at a much lower level than what I was actually acting on? So again, these are guidelines, not hard and fast rules, right? So there is no silver bullet, and I couldn't resist the pun, but test it right, sleep better at night, because what would a PowerPoint slide be without some useless puns and a light bulb? Because you have to have that. That's a requirement. Okay, so after our talk, and I'm gonna real quick, I'm gonna deviate because I see, for anybody who missed the link earlier, there's the link again. This is a continuation on a talk that me and a colleague Artem did earlier this week. But I got a bunch of questions after our presentation, and unfortunately, we didn't have time to dive into all of them. And so I have compiled a list of them here and kind of cleaned them up and reworded them a little bit to make them a little more generic. But they were great questions that I think are probably very relevant in a lot of cases. So So question one, working on a legacy code base that's gone through several revision, no tests written in the beginning, code not written with testability in mind. For most of us, this is the standard brownfield development mentality, right? I work for a professional services company, which is a consulting firm. A lot of times this is the situation we get called into, right? There's some legacy code, testability was an afterthought or non-existent, right? And then the question being, what are your thoughts on adding unit tests for such legacy code? Is it worth even adding the tests? Should tests only be added when bugs show up? And this is a great question, right? Because oftentimes people come into these legacy code bases and it's how, like, you can look at it, go, this is hard and unwieldy. One of the things that Artem and I touched on in the talk was the idea that testing actually makes developers happier. We like tests. Like, we like knowing that we can make changes to a code base and we didn't break anything. You can, anybody who's worked with any large project has probably heard this whole idea, well, don't touch that because if you touch that, this other stuff breaks. And it's like, really? How was I supposed to know that? Was there a test? No, there's not a test, but there's this, tribal knowledge that we all have that says you don't touch class foo because the whole world falls over and we don't know why, right? It sounds ridiculous to think about people using like appeals to ignorance to justify it, but it happens a lot. And so you get into that mindset of, oh, I can't touch code. Now you're fearful of the code, and it's like, well, I don't want to change anything. Sorry, slight tangent. But adding tests to a legacy code base. So my opinion is yes, it is worth adding tests. Now, it is rarely in a business best interest to spend, depending on how big the project is, hundreds of dev hours going and writing tests for all of their stuff, right? That is rarely worth it. And yes, gives a comfort level. Yes. Oh, or in my case, reduces my anxiety. Because there's anxiety when I don't know if I've broken things. But because there's likely not to be business time allocated to just writing a ton of tests of over everything that's not tested, it's probably not in the business best interest. Now, sometimes that does happen. We've been called in on projects where people are like, we've got this business critical application. We're tired of there being tons of bugs. Please write tests. Please automate the tests. This is, we've got, every time we do a release, it takes our QA teams, 2 weeks to test it all. We'd like to automate that process so that we can get releases out the door, right? Sometimes the business actually goes, hey, tests are a good thing. Let's build them out, right? That does occasionally happen. But just blindly doing it without that directive, you shouldn't just go and do it. So should tests only be added when bugs show up? I would probably extend it a little beyond just when bugs show up. In an ideal situation, you should write so Kevin's opinion, you should write a test anytime the requirements of what you're working on can be easily captured with a test, right? Because there are some features that come down the pipe that are not easily captured in those requirements aren't easily captured with a test, right? We'll get into some of the talk because I know there's questions coming up around like UI testing and unit testing stuff later on as well. But even some that are more like subjective level things of, I want this to look pretty. Okay, great. Like we have designers when that go out and are tasked with, hey, we'd like you to fix up the design of this site. And oftentimes their pull request is going to be a bunch of like CSS changes. Right? Is it worth writing a test over that? Not as much, right? That's does it look right? Okay, there might be elements of it that are worth testing, right? Like you can imagine the Essential C# site. I showed the little hyperlink icon. If you hover over the heading, right? Maybe it's worth writing a UI test to make sure that, hey, when I move the cursor over the heading, I expect to be able to copy the link, right? That's a very firm requirement that I can put into a test. Does the heading look pretty is not a firm requirement that I can't put a test on. So figuring out where that goes. When adding domain logic and features, bugs occurred is too late. Yeah, though, depending on what it is. So even on the domain logic and features, sometimes I think it is still worth building out the tests for it. So even on legacy code bases, there's often an element of still building new stuff onto it. And again, it depends on exactly what is going on. So this is very subjective. But sometimes you're bolting a new thing onto an old code base. And so that new thing can sometimes be written in a way that is testable and does work well. Sometimes you're, interweaving in with the legacy code, and that's not as reasonable to do. Right? So it depends a lot on exactly what's being done. A test for when a bug shows up is, and the comment there about a bug occurred is too late, is absolutely correct. If you write a test after a bug shows up, what you're effectively writing is a regression test to make sure that the bug doesn't re-break later, right? Your test didn't prevent the bug. You're just preventing, future you from reintroducing the bug. That's what I meant was time to write tests. Perfect. Yes. So writing tests when bugs show up is good, and it can be helpful. But one of the things that I've been trying to get one of the teams that I'm on to do is to identify areas in the code that are especially problematic, right? Because we can all probably think of this when looking at our repos. What areas are the worst? In my dream picture, what I would love is to be able to have like a class diagram overlaid with a heat map of bugs. That's what I would love. The problem is that's getting that correlation from bug to class diagram is not always trivial or obvious. But if I could have my ideal thing, I would love that, because then that would go. Hey, Andrew, yes, tonight is on testing, and I'm going to redrop the link. This is a bit of a continuation on a talk me and a colleague gave earlier. But yes, yeah, it helps guard against the regression of bugs. Absolutely. But it doesn't stop it. And so if you can identify areas that are especially problematic, it is potentially worth writing tests around that area. So if there's an area that's identified as problematic and the requirements of that area are fairly well known, it is probably worth considering writing tests around that area. Now, again, I think both of those two things have to be easily identifiable. And again, this is very subjective. Now, there's not an easy way to do this. If there's an area that's problematic and the requirements are well known, writing tests around it to verify that those requirements are met could potentially save you future bugs and pain, right? And at minimum, getting that code into a state where it's either more testable and cleaned up, makes it easier to fix bugs into the future. Even if they don't necessarily stop them, just getting it structured that way will set it up for future success. The other thing that's worth considering is how often the code is expected to change. Now, if there's bugs being filed against it and people are going in and fixing them, that means the code isn't stationary or static, right? It's being modified. I joked with Artem that, if you never need to update or change your code again, you don't need to write tests. And he kind of gave me a bet. Well, I don't know about that, but I was like, yeah, hear me out. Like, if it never needs to ever change, you don't need to write tests. Now, I count changing as if somebody files a bug and you go in and fix it, you're changing the code, right? And rarely is there ever a situation where you aren't changing code. But if somebody has an enterprise application that nobody's touched in 5 years, Should you go and write tests over it? Probably not. If no one's had to touch it in 5 years, is it really worth that in the test? Probably not. Like, the tests are giving you that design feedback, and if you aren't really designing anything with it, it might not be worth it. So we had a feature around scheduling inspections and have tests around the core functionality and the edge cases really cut down on the amount of bugs after release. That is awesome. I love hearing that. I will brag on a couple of my coworkers real quick. So I got a message from one of them, said, hey, we're having this threading problem. For some reason they think I know something about threading. And they're like, would you mind pairing with us on this and taking a look at it? And I'm like, sure, why not? A threading problem sounds like fun. Let's do it. So I jump in a call with them, and they share their screen. And the first thing they go is, okay, so we wrote a test. And I went, hallelujah. I was like, thank you. Thank you. They're like, we were trying to track this down. Because one of the things that gets missed a lot is that your test runner is probably a lower cost startup than whatever app you would be manually firing up yourself anyway, right? I really love it when I've gotten a section of code to the point where I'm working on the code, I'm writing the tests, and by the time all of my tests are green, I run the app at the end just to make sure everything's fine. But I have such a high degree of confidence that everything's working after my tests are done that running the code is just making sure everything's looking right and it works the way I expect, because I'm really confident that my tests have covered it. That is one of the most wonderful feelings ever. There was a comment I got from John that really kind of stuck with me of you can't really get somebody to understand what this is like until they go and do it themselves. The example I used in the talk earlier this week was the idea of, I can show you pictures of my vacation and how wonderful it was, but unless you go there and experience it yourself, it's not the same, right? And with all of this testing stuff, all I can do is show you pictures of it. I can just tell you how wonderful it is, but until people actually get to work in that environment and experience it, it's really, really hard. So, for what it's worth. Okay. So, one other final point on here. The cost of new tests on legacy code is quite high because of the cost of refactoring it to make it reasonably testable. Often the tests are written without refactoring the actual production code, and that bloats the arranged portion part of the test to being unreadable monsters, which I get that. Though there's a few things I would comment on this as well, right after a Mountain Dew. So, one, a statement I made in the talk before was that the quality of your code will tend towards the quality of your tests. So for those of you who've taken advanced mathematics and you're familiar with limits, you know how a function will tend towards a value. My opinion is that the quality of your app's code will tend towards the quality of your tests. So if your test project is the Wild West and things are chaotic and crazy, your app's code is going to start to tend towards chaotic and crazy. It might not, but it will start to lean that direction, right? The tests give the guide rails. It goes along with the broken window theory of coding as well. The idea that you should fix the thing that's wrong, because the moment you say, well, that's a low priority thing, we'll just ignore it. Well, then the next low priority thing gets ignored. Then the next one, and things start to compound on top of each other. Whereas if you insist on a high degree of quality in your tests, it's going to be very difficult for your code to start to drift. So bloating the arranged portion of the test, I often spend quite a bit of time, refactoring my test projects. People get really hung up on this idea of making sure that tests are clean. A colleague of mine, I was pairing with him earlier today, and the moment he had to duplicate a piece of code, the first thing he did, and he's a writer fanatic, so Go writer, is, you know, highlight the code, extract into method, boom, boom, done. Right? He's like, nope, we're not duplicating this. You know, if I need this thing in 2 places, darn it, I'm going to put it into a shared method. I'm going to name it. Sometimes pulling things into a method just so that a chunk of code can have a name associated with it, right? Sometimes people get this idea that, oh, well, it's not worth putting it in a method unless I need it in multiple places. Sometimes it's worth putting it in a method just so you can attach a name to a block of code. Right? You can put a comment above it, but the problem with comments is comments don't always give you a clear start and end, and comments can very easily drift away from the code that they were commenting. Right? It's very easy for them to find comments in the code that have no relevance to the code that they're commenting and going, what the heck? Whereas a method, the compiler is going to check you. You aren't going to mess anything up. So sometimes a method is actually worth it just to attach a name to something. And so if it's bloating the arrange portion of the test, my first question would be, could that be refactored? Again, without changing the production code at all, could the test code be refactored to make it not an unreadable monster? I think in a lot of cases, I can get even unreadable tests down into a readable state. And then they also go back to the idea of, if the test name clearly spells out what I'm testing, I would hope that I could get the arrange portion down to something that resembles the test name. Start with visual tests first, if need be, before refactoring. Make sure you don't break it, but reducing coupling is beneficial in and of itself. Yeah, and that's a strategy I've seen mentioned many times for people working in legacy code bases, is before changing the method, especially if you look at a bit of code and you're not sure of exactly what it's doing, sometimes writing some tests over exactly what it's doing and then going and doing the refactor can be quite helpful. Right? Just to start getting yourself to that point where then you can make sure you aren't breaking things as you go. That is a strategy I've seen in a lot of refactoring. Have you reached out to Mountain Dew for a sponsorship yet? You joke, but I've actually looked at their website and they actually have a page up that says not accepting new sponsorships. So have I reached out? No. Am I aware that such a page exists? Yes. I don't know if that's good or not. Okay, next question. Often when working on Windows desktop applications, there's a common pattern of don't test or don't unit test UI code. This can result in developers putting additional code in the code behind, since it's less work due to the lack of testing required. How can we convince people to implement separation and test into such a code base? So there's a couple great bits in here. So confession time. I think I'm no, I have not written a GitHub action for that, Benjamin. So first, the comment of don't unit test UI code. So I do a lot of WPF work, and WPF is notorious for this. Of the UI portions of WPF are pretty well ununit testable. They are very, very difficult to, and specifically I'm going to say unit test. And the reason comes back down to how they're structured. There's a lot of static coupling built into the UI classes, specifically system.windows.application. It's a nightmare to deal with. They require your test to be running on an STA thread rather than an MTA thread, which most testing frameworks are going to be running as. So you end up having to do some work around that as well. And then oftentimes, because to unit test a UI component, you have to basically simulate the WPF shell or the window in order to get it going, which is not usually very trivial. So what is STA versus MTA thread? Great question. So it's single-threaded apartment versus multi-threaded apartment. I believe I've got those terms correct. Effectively, UI thread versus background thread is what it comes down to. So with WPF specifically, UI components can only be accessed from the STA thread that created them. Little known fact, you can have more than one UI thread in a WPF application. Not common, but is possible, which is why I say that the user control can only be touched by the UI thread that created. Most people think of it as I have my one UI thread and then I've got a bunch of background threads. A lot of times that's realistically all you have. Sometimes there's more. Not often, not common, but it is there. Yeah, and the subtle differences. If you actually get into like the system.threadings.thread APIs, you'll see those two values come up. I believe there's an enum on the threads constructor, if I'm not mistaken. But we so rarely create threads ourselves, in C# at least, because threads are heavy. For fun, create a thread and look at how much memory it allocates. It's about a meg. Like, there's a lot that goes into spinning a thread, which is why you should probably rarely do it ever. We have things like TPL, the background worker queue, all this stuff at our disposal. Rarely is spinning a full thread the right solution. Not saying it's never the solution, because there's certainly times where it comes up, but it's not always. If you're spinning a thread, you should be real intentional about why. So coming back to this, so don't unit test UI code. So with all of that on WPF and how miserable it is to unit test, I will admit I helped the team write a definition of done, and I may have included a line in there about about UI code specifically. Thread pool. Thank you. Yes. Another good thing to use rather than spinning your own thread. But I may have put a line on that definition of done that said something along the lines of, XAML and XAML.cs files don't need unit tests. So pretty much fell right into this common pattern. And that was largely based on the idea of, hey, I know how difficult / impossible it might be to write this test, only because the framework that you're built on really wasn't made for it at all. Like, no. No one would accuse WPF of being testable. So I totally get the common pattern and doing it. However, with that said, we often push to move any business-related logic out of the UI code. So developers putting a code in the code behind, since it's less work, there's a subtle switch happening here where the first part is related to a technological limitation and the second part is related to a people problem. And there's an interesting conundrum that I've noticed a lot is oftentimes there's a desire to solve people problems with technological solutions, and it just never works, ever. To the point where I'm convinced that you can't solve a people problem with a technological solution. Which is part of why Artem and I wanted to do this testing talk, because the biggest testing problems we see are people problems, not technological ones. So the idea of developers putting code into the code behind to avoid needing to write the test, I don't think is really a technical problem, and it's a mindset problem. If the developers are viewing the tests effectively as regression tests and not as design feedback. If the tests were being used as a way of designing your code and getting your thinking correct, the code wouldn't have been put there in the first place. So I think the answer here is a little bit of, one, I totally get this, of don't unit test UI code. Yeah, we strive for no code behind files except for controls. Yeah, we do something similar, though we also will leverage behaviors and whatnot in various places. And there's always value converters that might do some interesting stuff, but value converters are relatively testable. Behaviors, rough because behaviors often are registering up for events. But yeah, you don't. Yeah, in WPF, you don't actually have to have the code behind file. That even though it shows up on the default item templates when you create it, you can just get rid of those. Like they don't need to exist. And people actually, they know this in WPF, they just don't realize it because there is an item template that you can gen that doesn't come with a code behind file. It's a resource dictionary. And so people intrinsically know, oh yeah, user control comes with a code behind, resource dictionary doesn't. They don't realize that, one, you can add a code behind to a resource dictionary. You probably don't need to, but you can. And you can drop the code behind from the user control. So for what it's worth, those are just two different starting templates, but you can beat one into the same setup as the other. If it's put into the code behind, then it'll be for UI test, right? Same thing. So yeah, you are correct. If you put it in the code behind, the reasonable place to test it is a UI test. That is absolutely correct. The disadvantage is if the expectation is that, because I've seen a lot of cases where UI tests don't get written, because the further to the right you get, the cost of building the test goes up, right? Unit test is fairly cheap. Then you get like your functional and integration tests. And I wrote a blog, but hang on, let me grab that blog. Let's see. Potech, shift left. Yay. Boom. Yeah. So I wrote this blog post. I'm going to get rid of all the ugliness on the end of the URL for everybody. But because people often get hung up on the categorization of tests, and categorization of tests is good to some extent, but it gets applied in a lot of places where it doesn't matter. And so this is often, like, I usually try to describe it to people on this idea of a gradient, right? Assuming you're in a .NET land or a compiled language, your very first test is your compiler. Like, did you type the right syntax into the file? And everybody's developers, we just accept that this is our first test, right? We don't even think about it as a test because it happens so often. But the compiler is the first thing that's testing to make sure that the code we typed is actually legit, or at least syntactically legit. And then we get into like unit testing land of fast tests, and then we move kind of into our integration, functional, slower tests type things as they move across, and maybe some automated UI tests as we move further over. And then we get into like manual monkey clicking QA level tests. And then whether you like it or not, any software worth its salt has users, and your users are going to exercise your code, whether they want to or not. And if you're building something for like an enterprise app, they may be forced to test your code whether they want to or not. So I oftentimes try to look at it from a gradient perspective, because people get really caught up in where's the line between unit test and integration test? Where's the line between integration and UI test? And again, I don't have fixed lines. They're blurry, right? And it comes back to knowing what exactly is it that I'm trying to test at each level. Acceptance tests, yes. Yeah, and I think there was a list of different testing methodologies that I saw, and I went through the list. I'm like, oh shoot, I didn't realize there was that many. There was like 16 of them on there. I was like, really? That's a lot. But when you start polling people to ask them about the various types of testing that they do, there's quite a bit, and the definitions for each can vary from team to team a little bit, which is really messed up. Oh yeah, mutation testing, fuzz testing, behavioral driven testing. Yeah. So the thing in here that I would argue for, so the second portion of this, I would argue, is a people problem, not a technological problem. And I think, how can we convince people to implement separation and tests into such a code base? I think is to, one, start with trying to change their idea of what tests are for, right? This sounds like the idea is that tests are a second-class citizen, and that tests are written after the fact and not worth as much. Until that mentality switches and the idea is that the tests drive the quality of your code, and your code is going to tend towards the quality of your tests. Until that mentality changes and people understand that, hey, I should be using tests to design out this, and I need to have this quality here, this won't necessarily change. There are people's solutions to some of these, like one of the oftentimes doing consulting work, we will push teams to go through and like sit down and legitimately write a team working agreement. Like if part of the team is really unhappy about code being pushed into the code behind, actually hash it out and have the team come to an agreement of, okay, we're going to put in our team working agreement, as much as possible, don't put code into code behind, right? That's something you could get a team to do. And then hopefully there are code reviews happening. And then once there's a team working agreement, there hopefully is no debate, right? If a pull request opens and a developer's loading up a code behind, it's like, whoa, 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 whoa. I thought we said we weren't going to do that, right? There's a team working agreement, right? Everybody agreed to this. Why, like, go change it, right? There shouldn't be much argument at that point. But again, at that point, it's all a people problem and not a technological one. So I think the key thing to convince them is change the mindset. And then after that, it's going to be a people solution. Mutation testing is the one to discover how good your testing is. Yeah. You didn't add a feature until you have tests to prove it, and you shouldn't have to create a controller window to do that. I mostly agree with that. The only exception I'm going to put on there is there are times where we get user stories about making sure that a particular UX interaction works, and you can only prove a UX interaction works by having some sort of UI interaction portion of the test. Now, whether that's an automated test or a manual one, that is always up for debate, right? One of the projects I work on, we have a piece of software that's used for working with video. And one of the requirements that we often get is this file should work in the player. That's not an easy thing to capture in a test, right? That's a very loosey thing, but it's also something that really requires having some sort of UI. Like, I can crack the file open and start looking at the data of the video, but we work with so many different types of things that it's what is correct is a real gray area for us. Okay. So abstractions are an overhead. Some think that code gets more complicated to read and follow when abstractions, i.e. interfaces, are introduced. They can be seen as a necessary evil in order to be able to mock dependencies. What are some good arguments in persuading people that abstractions are worth it? Yeah, agreed. Domain features, not UX, to prove that it's done. Yes. And on the team that I'm on now, we actually even went to the effort, because we're using DevOps pipelines. You can get code coverage add-ons that will even auto block PRs if you want them to, if the code coverage of new stuff in the PR isn't appropriately covered. So we don't have it blocking the PRs, but we do have it posting the code coverage right on the PR. That way it's real obvious to everyone what the code coverage is of the PR. And if your code coverage is crap, you can probably expect a comment. Ooh, great question. Do you use JustMock or TypeMock to mock third-party dependencies that doesn't have interface virtual methods? I used it to create a wrapper adapter, but it's tiring to do it every time. So I have used JustMock in the past. I haven't used TypeMock, but I'm going to go out on a limb and guess that it's a similar situation where it allows, quote unquote, mocking of static methods or whatnot. There are a number of libraries out there that give you access to do that. Hold on, shameless self-promotion time. Shameless self-promotion time. I even got annoyed with the lack of stuff at one point. and I wrote a library called Noseplug that effectively does static level mocking. So it has a very mock MOQ type style. It leverages Harmony to monkey patch static methods, which does come because it's built on Harmony. There are some limitations of Harmony that are worth knowing about. Specifically, method inlining can really hose you with this library, but it is an option, and it's worth noting. Sometimes you have to test code that smells. I tried to name this library very appropriately to point out that this is a band-aid over a different problem. It's not a solution. Just to throw that out there, right? Sometimes you have to use something like JustMock to go after a dependency that is not easy to get at, and there's not a good way around it. So have I used those in the past? Yes. They are, if you are working in a legacy code base or for whatever reason you're working with something that you are unable to change, whether it's your code or a third party, because sometimes you're not unable to change your own code due to other constraints, right? Sometimes in those situations it's worth doing. The big risk factor with a lot of these static mocking libraries is you oftentimes find yourself using them as a way of smoothing over what otherwise would be a nice test, right? Of, as part of this method, it's going to call this third-party library. I can't do that as part of my test, so, I'm going to use JustMock to break it, which is fine. It's just worth noting that then your test has some coupling then into the implementation. Right? Anytime you use one of these libraries to mock a static, your test, in addition to the method that you're testing being coupled to that static, your test is also coupled to that static as well, which starts to bring things together. So if refactoring is possible, that is generally preferable. However, refactoring is not always an option. So where possible, a refactor is good. Now, I'll circle back to this question more in a minute because I want to kind of address this. A good example for abstraction is datetime.now. And so it's funny you bring that up because that's one that's actually changing in .NET 8. Because since the dawn of time, datetime.now has just been a static property, and now they're putting in a method of being able to make it behave deterministically, specifically for tests. But yeah, Noseplug, I use it for things like datetime.now, where it's like, I don't really want to put an abstraction between my code and datetime.now. That's kind of a worthless abstraction, right? And that's kind of what's being hinted at in this question here, right? If I'm going to go after datetime.now, I can put datetime.now behind an interface for no other reason other than my code no longer uses datetime.now. Instead, it uses, insert my datetime interface. And I'll use that so that I can make my code behave deterministically so that I can, test dates in the future, test dates in the past, do things like leap year or daylight savings time shenanigans, that kind of thing, right? Because I don't want to trust that I have to run my tests at those times of the year. I just want to put it into that state and go. And that is certainly a possibility, and there is a time and a place for that. One of my colleagues' favorite questions to ask people during an interview is, what's the difference between an interface and an abstract base class, and when do you use each? And to some degree, I hate the question, because anyone that I'm interviewing, if the person has a computer science degree, a bachelor's of science, 4-year university degree in the US for those people outside, that's one of the kind of like academic questions that I would expect any graduate can at least give me an academic answer of, right? I usually like to ask the question differently of what is an interface and how do you use it? Because my opinion, our interfaces are one of the sharpest types in all of .NET. They are so easy for anyone to declare. And they are so often done so poorly that it makes me twitch. Like, they are one of the easiest things for people to get wrong. And I say that because on an interface, like, all you have is, member declarations, right? It doesn't help that latest versions of C# added things like default interface members, access modifiers on interface members. Those things all got added, making it even easier for people to misuse an interface. Drives me crazy. But interfaces are very easy to mess up because they really require you to be really conscious about your return types, the names of the members on the interfaces, the parameters coming in. Because if you just slap oftentimes what I'll see people do is they'll declare a class, they'll do all the work in it, and then they'll realize, shoot, I kind of wanted to mock the usage of this for a test. Oh, I know, I'll make an interface and I'll just copy all of my method signatures into the interface. Done. I'm like, oh dear heavens, no. Please stop doing that. That is horrible. Because an interface, because what the computer science graduate gives me as an academic answer is, well, an interface is a contract, right? It declares how two things are to talk to each other, which if you are a college graduate being interviewed by me, expect the question. And if you give me that answer, you'll be okay. That's fine. If you want to get the gold star, here's what you should hint at something more like this. Beyond just a contract, the interface is where you actually design what the code should look like. And this is where, if you're using interfaces and TDD, this is one of the prime places where you can start to leverage it, because it will start to give you an idea of, is this a good design? Yes, I like that phrasing. Communicates intention and responsibility. Yes, that would earn a gold star beyond just a contract. And once you realize that the interface is supposed to do that, you start to look at the names of members on interfaces and go, hang on, wait, do those things go together? Does that name even make sense? Maybe it makes sense on the implementing class, but does it make sense on the interface? Right? And so being able to build those types of things out, they are so easy to mess up. I will say on this question here, abstractions are an overhead. I will agree with that. Having an abstraction is a bigger overhead than not having an abstraction. 100%, I can agree with that. However, the abstraction there is more than just a necessary evil, I would say. It's in some cases desirable, because the necessary evil comes into play when people are like, I want these two classes to be coupled together. Right? To call the interface, if you have, class foo calling class bar, right? If there's no interface there, foo calls bar, everyone's happy, right? There's coupling between those classes, so be it, right? Foo is coupled to bar. If we put bar behind an interface and now foo talks to ibar, right? Now we've decoupled them. Rather than a necessary evil, the question should be, is that coupling desirable or not? Right? If you're putting in the interface just so that you can mock something where that coupling was desirable, you have caused a problem. Because I don't actually like the idea of just slapping interfaces on all my dependencies. Sometimes I like using the real classes. Why not? Right? People who get mock obsessed, using mocks for all of their interfaces, can have great code coverage and will often still find bugs in their code. And the bugs will creep in at the point where the mock that you've made on your interface, the way you've set up the mock doesn't match the implementation that your app is using. So if you have no assurance that your mock of your interface is matching the behavior of the implementation in your app, you've now just left an opportunity for bugs to creep in. Now, I am not saying mocks are bad. I'm one of the maintainers of the auto marker library. I love mocks. Mocks serve a purpose. However, I see people overuse them, and oftentimes they overuse them specifically coupled with interfaces because they go, I know that in order for this thing to work, I need to mock wants an interface, or at least something with virtual members that it can override. Yes, but breaking that coupling may not be necessary. I used the example earlier where I was testing a class that had some tight coupling to another class. I didn't bother to test the delegated class that it was calling into. I just tested from the top level to make sure that the interaction between all of those classes worked as expected. I don't care, right? If that coupling exists and my top level entry point going into those classes works, I don't care about the stuff under the hood, right? Now, with that said, mocks are still very good when it's like, I want to make sure my code handles, this particular exception correctly, right? I need my dependency to throw an exception in this case. Great. Mocks are golden for that, right? When you have a requirement that says, given this behavior, I want to do Y, that's where a mock will shine, right? Yeah, it's better than having some large implementation with a nebulous design that doesn't communicate its intent and purpose. That is true. That is true. And that's where I would argue that if you have a class calling into something that is, large nebulous name that doesn't communicate its intent or purpose, there's probably some potential refactor to go in there. And this is where TDD really helps, right? Because when you start looking at it, if it's difficult to either name your test or understand what the test is doing from the name, this is actually one of the things that I love about Copilot. Copilot, when you write your test, it'll try to write your implementation for you. And it blind guesses. But it guesses based upon the patterns that it's seen in your previous tests and how you formulated your name, which is pretty cool. Because if you're consistent, it means it just writes tests for you and it eats your stuff for breakfast. But what's really interesting is when it's wrong, right? Because when it's wrong, it oftentimes is guessing at what the API should be. Because it's going, if you were consistent everywhere, this is what I think your API should be. Now, not saying you should rename your stuff to match whatever Copilot says, because that's probably horrible too. But it's interesting to at least consider, right? And say, oh, that's interesting. Would that be a better name, right? Would that be a better structure, right? Because it's just blind guessing, right? It's going, well, I think based upon what I know that it'll be this. And I should say blind guess. It's a really smart, educated guess. But it's an interesting thing to look at and start to realize that if you're writing the test first around what you want the requirements to be or what the requirements are, and you're capturing those in a test, oftentimes I like to let Copilot just write out that implementation, and then I look at it and go, okay, let's consider if that is a good structure or not, right? Does it align with the requirements? Because if I've named my test well, it's often trying to infer what my arrange, act, and assert should be based upon my name. And, sometimes it's wrong. It's like, no, stupid Copilot, don't do that. You're wrong, right? Because it's not brilliant, but it's worth doing. Circling back, what are some arguments to persuade people that abstractions are worth it? I think what I would say here is I think both sides are probably wrong. And not necessarily wrong per se, but potentially approaching it incorrectly. The idea that you should slap an interface into mock, I think, is incorrect. I think the idea should be you should use it to evaluate coupling, and then interfaces should be evaluated on their own without regard for the implementing class, right? Interfaces should be evaluated from the caller's perspective, right? Is this the right API? The phrase that phrasing that you put in there earlier, Blue Spider, about communicates intention and responsibility, I think is a good way of evaluating when looking at an interface of, does it communicate the intention and responsibility of all implementing classes? And some people are like, well, we only have one implementing class and then we have a bunch of mocks. No, each mock is an implementer of your interface, right? And your test goes against it. The audience of it. So I think I would say that is evaluate it there. And then going on the other side is, I wouldn't always say that abstractions are always worth it. I do think there are times where tight coupling between two classes is perfectly acceptable. It just means, and this is something worth evaluating, right? If I've got class foo and it's tightly coupled to bar, if I can test all of foo and the fact that it's tightly coupled to bar doesn't matter to my tests, I don't care, right? Bar is an implementation detail of foo. The fact that they're tightly coupled doesn't bother me in the least, right? If I can test foo just fine, I don't need to have an I bar, right? Bar can just be there and they can be tightly coupled. Now, if I can't test foo because of bar, now we might question the coupling, right? And that's where you start to go back and forth. I'd like to see good examples of that. I will see if I can put something together, because the sample I did earlier today is unfortunately in a business project and I can't share that code, but I will go and look. So we don't need to mock everything. No. Oh, here's an example I can share. So, project I was working on was using Newtonsoft for JSON serialization, right? Newtonsoft has been the top JSON serializer for many, many years. Tops the NuGet chart download numbers and all that stuff. So many people are familiar with it. But the project I was working on didn't want to couple themselves to Newtonsoft, so they put it behind an interface. Right, so the actual serialization was behind an interface. But as part of the test, so serializer behind interface, right? Move on. We're now testing class foo. Class foo needs to use the serializer. And so in foo's constructor, it took in, the interface for the serializer, and then in its method, it was using it. And I made the comment because I was looking at the unit test for foo, and I was like, you're mocking away the serialization. Why not just use the serializer? Because again, I'm an AutoMock person. I love it. I'm like, just give AutoMocker the real serializer instance. Don't do this weird mocking on the interface for the serializer. Just give it the real one and turn it loose, right? Why do we care, right? So foo at that point was doing it, but rather than necessarily mocking it away, and I wouldn't have been too disappointed to see foo, if it wasn't for the way the rest of the project was structured, I wouldn't have been opposed to foo accessing newtonsoft.json directly inside of the code, right? To do its serialization. Do I care that foo is tightly coupled to Newtonsoft's JSON serialization? Not really. What I cared about is when I call foo, do I get the behavior that I would expect? And a big portion of what the method on foo was doing was cloning some objects using JSON serialization, right? So for people unfamiliar with it, a cheap trick to get a deep clone on an object is serialize out, deserialize. Now I've got new object instances with the same data. It assumes your data type is serializable, all that jazz. Plenty of caveats, but it's a cheap trick when it works, right? And for POCOs, it's perfect. But I don't care if foo accesses a serializer directly, right? And if it wants to do that serialization, great. right? That's an implementation detail. If I'm testing that foo is effectively doing a clone per se, right? What I'm interested in testing is, do the instances I get back, are they A, different instances than the ones I sent in? And two, do they contain the same data, right? And this might be a case where an approval test would be a very reasonable way of approaching it, because you've got potentially a deep object structure that you want to compare, right? Makes it easy to see those separations. So I think for this, like I said, I think I would argue that necessary evil is potentially the wrong phrasing, and that you don't need to mock everything. However, you should evaluate your dependencies to decide what should be mocked, right? Mocking and interfaces should be done intentionally in your code with thought. They shouldn't just be a blind, oh, I put an interface there. That's probably the wrong one. Coupling often leads to issues in my experience. That is true, right? Coupling is definitely an area that can bite you in a lot of places. And coupling can even come in very subtle ways, like the datetime.now case, right? It's real easy to have code that uses datetime.now. Kind of a pain to test, right? And so those types of coupling things can come in. But again, I think the key thing is to evaluate those dependencies and decide on whether they are an implementation detail or an appropriate place where you should put a seam in your code. Right? I think that's the key switch I would make there. So let's see. When something doesn't depend on heavy time-consuming dependency like database or timer and contains just log, it's usually fine with tight coupling. Yes. I think that is probably a fair phrasing. Like I said, I would just make sure it is just very intentional about where you take the coupling, right? Coupling should be an intentional decision as well as dependencies. And I think oftentimes people try to approach it from one of the two extremes of, I just always throw an interface, and that way there's no coupling, or I always tight couple all the things. And both extremes I think are wrong. I think the right answer is being intentional in the middle. And so you never think about Bison for clone. I've used it in the past. In this case, the project was already using Newtonsoft, so it was an easy win. But yeah, there's other options for going through and doing it. In our case, because it was already an object that was being serialized to JSON for other purposes, it made it an easy way to clone it. Also dispatcher. Yeah, dispatcher's a fun one, specifically in like the WPF dispatcher, because it is one of those areas where your code often will need it. And this is an artifact of WPF's framework. So past videos I've covered like the community MVVM toolkit. One of the common problems with the relay command that is there is you can call, what is it, notify can execute changed. I think that's the name of the method on the relay command. The problem is you can't call that method from a background thread. And this is where things get awkward, because you now have a relay command, which is very much something that should live in your view model, and a method on that relay command that has to be invoked from a UI thread. And that can get really awkward really fast, because now you have something in a view model which shouldn't know about the UI that needs to care about the UI thread for when it invokes a method on a view model object. And it's really awkward. And so the common way around it is people put, this dispatcher behind an interface, right? And then have that thing that they go through a mock, which is fine. right? Like you can totally do that. That is an option. There is a pattern that I like, port adapter simulator. And the idea being that rather than using mocks for all of your interface dependencies, you actually write, let's use dispatcher as the example. We have an iDispatcher, right? You would have an implementation of iDispatcher, which uses your actual applications dispatcher class. It's basically just forwarding method calls, right? And then you have a second dispatcher that is used for a second implementation of it that is primary usage is for testing, but maybe all it does is directly invokes the delegate, right? Because dispatcher is going to have members on it like invoke async, where it takes in a delegate and just invokes that delegate on the UI thread, right? But for the testing one, your implementation just straight invokes the delegate. One of the things that can be very helpful to do is that if you write that second implementation of your iDispatcher, rather than just always using mocks for it, write a concrete implementation. And then more importantly, write tests for that concrete implementation. Right? That's the important part. Ideally, if you can, have tests that go against both the concrete implementation that is the application dispatcher, as well as your in-memory one. And then once you have assurances that your in-memory, the one that's just blindly invoking your delegate, is working, you then can use that in all of your tests rather than mocks, and that will eliminate the case where bugs sneak in due to you having a mock that you didn't configure to match the appropriate behavior, right? If I've got this implementation and I know that I want to make sure that invoke async, when I call invoke async on my iDispatcher, I expect that delegate to be called, right? If I do a mock without a setup, by default, it's not going to invoke the delegate on that parameter. And so everywhere where I expect it to work, I have to do a setup and say, okay, iDispatcher setup, when invoke async is called, grab the parameter, invoke that delegate, blah, 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 just so that my test works. But instead, if I write an in-memory dispatcher that has an implementation of invoke async, and all it does is blindly invoke the delegate, and I write tests to guarantee that that behavior works, I can use my in-memory dispatcher on all my other tests to make sure that I don't have that blind spot in my code area. The other thing that I tend to do a lot is, because I like AutoMocker so much, which, hang on, more shameless self-promotion. Okay, so again, shameless self-promotion. I'm a maintainer. I'm biased. This library, which is severely lacking in documentation, and I apologize for that. This AutoMocker instance basically acts as a lightweight DI container or dictionary of types. And so oftentimes I will write extension methods that basically pre-populate this dictionary with any of those in-memory instances that I want. Right? That way I can do, AutoMocker, add all my stuff, right? And it gets loaded with all my stuff. And then when I go, oh, okay, AutoMocker, create instance of car, I know that it's going to use my memory instances rather than mocks for, say, iDrivetrain or whatever it's going to be. Right? So it can save you a little bit of setup costs. And again, this just comes back to the idea of, if I see a test where it's a pain for me to write the arrange portion of it, I start refactoring until it's not painful anymore. And basically I go until I'm happy, which means I've improved my developer enjoyment. That level may be different for you. Doesn't WPF fact solve the calling the UI thread problem from a test? No. So the WPF fact attribute for XUnit, what that does is it changes the calling thread of your unit test. So XUnit by default, you get background threads calling each of your unit test methods. When you decorate it with WPF fact instead, it's not a background thread that's invoking you anymore. It's a UI thread. Now, that works around some problems, specifically if you're writing a test that goes against a UI object, because most WPF UI objects will do things like, am I being called from a UI thread or not? That STA thread. And if not, I throw an exception and die, and we all go home unhappy. So that's all WPFACT does. It doesn't fix calling the UI thread problem completely, because if the method that you're calling does something like, you know, await task.yield right at the beginning, everything after that is now on a background thread. So all WPFACT does is start your test on a UI thread. It doesn't guarantee that you will always be on a UI thread at the point you need it, right? So that may not always be an easy thing. It just starts the test there. The other drawback of it is it also makes tests slower. It also raises the question of, depending on what you're testing, WPFACT is fine if you're writing a test against something like a behavior that maybe, you know, your behavior needs to touch some UI elements, but, you know, we still want to test our behaviors. Great, fine. It works well for those situations. If you're using WPFACT on something like a view model, that's a red flag that something's wrong, because view models shouldn't need to know about UI threads. The relay command method being notwithstanding, but in general, your view models should not have UI objects in them. They should not need to know about UI threads. That's not a thing they should care about. Your view models are designed around the business logic, UX logic of the app that you're building. Oh, one other thing that I wanted to pull out. So inline API. So the port adapter simulator pattern that I was mentioning, and I will drop some links here in a moment. Let me find this guy. I don't know where. There's been so many refactors in here. I might take me there. Okay, so here we go. So here's some links. So link 1. This is iConsole, right? Very simple interface. There's not a lot to it, right? There's some extra interfaces here: standard out, standard error, standard in, whatever, right? Important part, this is an interface, right? Then there is terminal. I'm gonna go back. Code searches. Where is the implementation of iConsole? There it is. System console, test console. So this is a beautiful example of the thing that I was mentioning earlier about having 2 implementations, right? So iConsole interface, system console. This thing doesn't do much more than shell out to system.console, right? Straight up, that's its purpose in life, is it just hides system.console behind an interface, right? Test console also implements the iConsole interface. But you'll note there's a surprising difference here. This thing is not going straight out. This is just building up some string builders. And so it's completely in memory of all this guy is doing. It's just writing out to string builders. So it's completely in memory. Okay? And then if we go and look at the system command line rendering, is it rendering tests? I think is where this thing lives. Where is the... So this is worth noting. So you'll note the system console terminal test. This is not quite what I'm looking for, but this might be the level at which they were tested at. think this might be the way they were tested at. You'll note this is just a very simple test class that derives from terminal tests. Terminal tests down here are all of these tests are written against iTerminal. And I realized I was showing iConsole earlier, and I've switched to iTerminal, so work with me here. I didn't know I was showing this, so I didn't prep anything. Let's see. Test terminal. Terminal. One of these guys here is... One of these guys here has the alternate implementation. But this is where the terminal tests. Ah, there we are. Got it. This then is testing both the in-memory implementation and the real implementation against a set of common tests to make sure that they behave. Admittedly, not a lot. There's then some additional tests on the in-memory one to make sure it has some specific behavior that is not easy to have a common test against. But all of these tests mean that test terminal now ships in the actual main project. Test terminal doesn't live in the unit test project because we've got tests over it to say, yeah, this is a good implementation. It matches all of our requirements. Ship it. Why not? But it then means that in all of the tests where we needed an iTerminal, we now have an in-memory implementation that we can just drop in whenever we want and know that it's going to be a good implementation without any mocks. There are no mocks used anywhere inside of the system command line library, which surprised me, but there are no mocks in here. So it very heavily leverages the idea of we're going to write our own dependencies every time we put in an interface, which also really lends itself well to being intentional and thinking through those interfaces and those APIs, right? If you know that you're going to have to write 2 implementations every time you add an interface, you're real intentional about doing those interfaces. You're also real intentional about making sure that you don't populate the interface with too many worthless members, right? And by the time you're writing that second class, mocks unfortunately don't do a good job of validating your interface signatures, right? Because if all you have is the one real class that you wrote that implements it, the mock is going to just adopt whatever you put. But if you have to write 2 implementations of it, you start to realize really quick when you've got a member on an interface, it's like, that really doesn't belong here, right? This is real specific to one implementation and not the other. Okay, perfect. You've just identified a problem with your interface. Let's go fix it, right? So pros and cons to each. Okay, let's carry forth. I don't remember how many of these I've got. Let's see. This is a wonderful one. How do you ensure that the tests are good unit tests? Oh, I think they were supposed to be square brackets about unit a second time. And probably here too. There's too many unit tests in here. In the talk Artem and I did, I joked that I wasn't going to use the word unit test, and then I used it like 4 times. How do you ensure that the tests are good tests? Bad tests provide nearly no value and are just a hassle to maintain. I would actually argue that bad tests are not nearly no value, that they are negative value. Yeah. One of the earlier slides in the presentation, the comment that Artem and I made, our tests are not free. Right? Some people get this idea of, well, I wrote the test, now I'm done. No. Like, if you could write code and be done, developers would be out of a job, right? Code constantly is evolving. And if your code is evolving, your tests need to evolve too, right? Simple as that. Like if you've got requirements that are changing and moving, your code needs to constantly be moving and changing to come in line with whatever those changing requirements are. But on to the actual practical idea of how do you know tests are good tests? So the first and simplest thing to do, especially in .NET, is check code coverage metrics. A phrase that I've repeated many times is that
Code coverage is a negative metric. It cannot tell you what code is covered, despite its name, which is really unfortunate. They call it code coverage, and it really doesn't tell you what code is covered by a test. It just tells you what code was executed by a test. And maybe I'm being a little pedantic on the word covered, but whatever. What it is very good at identifying is what code is not tested. Code coverage reports are really good at telling you what code you have not tested. So the first thing to know if your tests are good is check to make sure that you don't have any gaps, right? Look for those uncovered bits in your code coverage report is the first way, right? Because if your stuff is not covered by the test, your code is crap. The other thing that I often do is I look at churn on the unit tests a little bit as well. And there's some pluses and minuses of this. Artem said it really well, is sometimes people get really unhappy when they're like, ugh, I made a change in my code and now I have to go update, 80 tests. And Artem made the comment that, people often look at that as a negative, but that is probably the wrong mentality of the test, right? If you're making a change and it's going to force you to go and update a huge number of tests, it's probably worth stopping and asking yourself the question of, did you make the change in the right place? Right? Maybe it's legitimate and you changed a method that has a ton of tests over it, so therefore you need to, right? That's possible. But it's also worth asking the question of, maybe you should question, like if your simple change is going to have all these far-reaching effects over your tests, maybe you should question if that's the right place to the change, right? Maybe it's wrong. Because your tests are one of the first areas where you get to understand the ramifications of your change. Like if you have a test suite that covers all of the requirements of your code base, if you make a change and you see a test fail, like resist the urge to just go and tweak the assertion so that the test passes. That's bad. But it can be quite helpful to say, oh, I didn't realize if I, tweak this thing here that it's going to break this other feature over here. We didn't think through the implications of those changes, right? That's the ideal situation, right? If your tests are capturing requirements, not implementation, but requirements, if you make a change to make, your new test pass, but another one starts failing, it quickly can point out, hang on, we've got requirements that are in conflict now. Right? And that's a sweet spot. When you have tests that are catching issues with your requirements, and you can go back to the team or whoever's putting together these things and say, hey, look, we've got these requirements that I know you asked me for new feature X, but you realize what that's going to do to feature Y that we did last month, right? How do you expect these things to work together, right? And you can start having that dialogue. That's the sweet spot. Like, mwah. So I would say if the tests are becoming a burden, look at the question whether your implementation's right first, and then consider the test. The other thing to keep a lookout for, there are a couple red flags for bad unit tests that always perk me up when I see them. First, the name. If I can't read the test name and know what's being tested just from your test name, it's probably a bad test. At minimum, one that needs to be renamed. Because the name should drive what I see in the rest of the body of the test. The other thing that is often nice to do, and I will often do this when doing code reviews, is because we always name our test project with .test on the end, which unfortunately means alphabetically they get put at the end of the list. I will often do pull request reviews from bottom up so that I'm reading the tests first and then going and looking at the implementations, right? Rather than starting from top down and reading them. Just with the way DevOps and GitHub order things, if you start at the bottom and go up, if your things are named with .test on the end, it means you'll be looking at the test before the implementation. And so reading through tests trying to block out the idea of what I know the implementation would be. As a reviewer, I have that nice perspective. The author doesn't get that perspective because they already have some preconceived notions in their head of either what they were going to write or what they did write. Either way, once they've seen it, you can't unsee it. So being able to look at it from that perspective. I would also propose that it is worth adding some tools to your toolbox, and I may try to con Artem into doing a few more of these talks around testing tools and application of them, because there's so many good things out there that are worth knowing about. A lot of people barely scratch the surface of, hey, just use one of the big name testing frameworks and you're probably fine. Like that's a good first step. But there's a lot of things that you can throw on top of that. I mentioned approval tests earlier, especially when you have deep object graphs. Like knowing when to use an approval test can save you a ton of time. If I see a test with 40 assertions in it, I start going, dear heavens, what's going on, right? Like, why are there so many assertions? And oftentimes the answer is there's a deep object model that they're trying to validate. Okay, we should talk about ways of validating a deep object model, right? Custom equality compares, approval tests, both of those better options, right? Makes it a lot easier to track down what's different between two different things, especially if you need something where you're kind of hyper specific of, I want to test these things. I don't care about the whole object, but I care about most of it, right? That's always the hard one. There are different things like looking at different assertion libraries. Some people really like the Fluent Assertions library, which does start to give you some of those nicer, deeper comparisons between types, though it doesn't give you the same diff view on the failure that an approval test would give you. Things like mock or auto mocker, I leverage a lot specifically for decoupling my tests from the constructor, because if you aren't using something like auto mocker to create the thing that you're testing, what ends up happening is as soon as you add a dependency, I think I have a sample of this. Yeah, so something like this. You'll note in this case, I am just testing my, so in this case, I am testing the increment counter command. I am testing its execute method, and I expect that it increments the count, right? And I'm already inside of main window view model test, so I try not to repeat main window view model in the test name because it's already there. But the idea being that it goes through, it grabs the initial count, it executes the command, verifies that the count was incremented by 1. Simple. But you'll note here, nowhere am I actually calling the constructor of main window view model. The idea being that if I need to add a constructor dependency, right? Maybe I add in an iDispatcher here, hypothetically, right? It's now, my AutoMarker has now decoupled my test from the constructor, and I only need to care about those constructor dependencies that are being exercised as part of this test, right? So things like that can save you a lot of headache for major refactors as well. The other thing, even if you don't like using AutoMarker, don't have your constructor invocation in every single one of your tests, right? That's a great example of an easy refactor. Just, private static main window view model create, right? And you can even make create take parameters. So if you don't use AutoMarker, have the creation of your system under test in a shared method. That way, if the constructor changes, you don't update 40 tests, right? You update one thing and you're done. And it's easy and your life doesn't suck, right? So simply refactoring those types of things out can save you a lot of pain and suffering, right? So aggressive refactoring of your tests are so especially if things are saying if your tests are a hassle to maintain, aggressively refactor them. Because the test project is one of the areas, because it's not shipping, and I don't want to give the idea that somehow the test project is less important than whatever you ship, right? But rarely do we ship our test projects, which means the usual guidance that people would give on legacy code bases of, be careful, don't touch too much, you don't want to break anything. Those rules generally don't apply to your test projects. Break stuff, refactor, aggressively refactor your tests so that they aren't a hassle to maintain. That type of refactoring pays dividends. I love building static factories, and there are other libraries around. What is the, not AutoFac. Shoot, I'm blanking on the library. There's libraries around doing factory methods for creating objects up with test data pre-populated in all the properties. Do that. And again, if you don't want to, if you can't use a NuGet package or you don't want to, static methods, right? They work great. If you've got some class that you have to create with test data for multiple tests, wrap that up in a factory method somewhere. Like aggressively refactor. Okay. Okay, and I think this is the last one we have here. What are some general rules of thumb to be regarding what should be automated tested versus what should be UI tested, specifically around desktop apps? Okay, so the first one that comes to mind is what I mentioned earlier about if the requirement is capturable, is easily tested, right? If it's something that's objectively easy to capture in a test, it should probably be tested. Now, where it should be tested is always a bit of a question. So I would, let's see, where is it? I would push for, it should be tested as far left on the spectrum as is reasonable. Not necessarily as possible, but as reasonable, right? Like I can do things with like WPF fact and threading, and I can make my WPF user control behave in a unit test. That's probably not the right way to test the control, right? Because I have to then make sure I'm calling the layout and the measure calls to make sure that all of the right events are occurring and that kind of thing. So it should be tested as far left as is reasonable, depending on what it is. For UI testing, hang on, I stole an answer from a colleague earlier. It's okay. I told him I was going to steal his answer. So this is acceptable. Also, thank you, Mike. Since you said you were going to watch the recording later. Hi. So shout out to Mike because he is tester extraordinaire, and I will happily go. So specifically around desktop apps, he calls out that if it's possible to design around it so that you don't need to UI test it and you can shift it left, please do that first. That is usual, because with everything on the testing spectrum, the further to the right you get, the cost of building and maintaining that test goes up, as well as the runtime of that test goes up. As you'll note on my graph, I focused around the time it takes to actually run that test, right? Compiler's fast, seconds, maybe less, right? Your unit tests also seconds, should be. Slower tests, minutes, right? Maybe pushing an hour or something, but like most, like if you're using Azure DevOps or GitHub, your stuff is going to start timing out at the 60-minute mark, so you're probably in the minutes or so in here. You get over into the manual testing realm, okay. I've seen people actually have numbers that have the word weeks following them, right? And then end user testing is as long as your release is live. So when possible, refactor to move it left, preferably all the way in. For UI tests, the idea should be to hit the critical paths as concisely as possible. So you don't need, for UI testing stuff, you don't need to hit everything. right? You need to hit the critical paths to make sure that the app is in a good functional state and that features are working, right? Unlike unit tests where the goal is to get a wide breadth of testing and make sure you've hit all of the specific scenarios. In an ideal situation, UI tests are written from the perspective of unit tests are already there, so we know the individual pieces work. Now we're just validating that the pieces work together, right? You don't need to replicate testing that was already done at an earlier stage. So once you get up to the UI test level, you're really just testing those connection bits, the end flow, things that weren't easily capturable in an earlier test. Let's see, what else did he say here? Yeah. He also commented that as much as possible, he tries to get it to where when you get down to manual UI testing, i.e. the monkey clicking of the QA people, that ideally what you want them doing is exploratory testing. So looking for things that may or may not be covered by tests. You don't want your QA people wasting their time on the well-trodden path that you should have already captured in your test. You want them poking at edge conditions, things that you may have not thought to test, right? You want them looking for other areas that may or may not be there. And then it's all about finding what are those critical paths and getting those automated first. So I think on this one, shift left is preferable for UI testing, getting the critical code paths, and to some degree, depending on how you structure stuff, you can kind of cut some stuff off with integration or functional tests of, okay, now we're going to put some pieces together and see how they play with each other and make sure that they work. And again, as you move right along that spectrum, try to avoid rehashing tests that were already previously done. Happy path tests should be done by devs before done. Yes, absolutely. I actually even advocate for some places have the tests written by QA or somebody other than the devs. I don't like that. I think devs should be responsible for writing all their tests, whether that be UI, unit, whatever. And not saying that QA can't write more tests. Like, that absolutely should be done. Like, in an ideal situation, if you've got technical QA people who are capable of writing tests, they should try to, like, they know their hot paths that they go down. They should try to automate their hot paths. But then having devs write that first round of tests, devs write code differently when they're throwing the code over the fence to somebody else to bug test, right? It's real easy to go, nah, that's QA's problem. We're going to make them do it. Like, if that's the setup, it allows that then allows a people problem to creep in, right? And you can't completely solve that by saying, okay, devs are going to write tests, because that usually just means then the lazy dev writes lazy tests. There's probably a people solution that needs to go in and address that as well. But having the devs actually build out tests for that kind of thing, like, you write code differently when you know that it's there. I actually heard about some situations, I think it was Microsoft, where devs were on the hook for any bug that was found in their code. They were on the hook for, even if they had changed teams. And not surprisingly, the number of bugs found in production dropped dramatically. Like, if you know that your phone is going to ring at 2 a.m. if somebody finds a bug in your code, you darn well make sure your code is bug free, because you don't want to be the one woken up at 2 a.m. So if you ship something and there's a bug in it, they call and wake you up. And I'm like, oh, that's a great way to get rid of bugs. Make sure people have ownership in the stuff that they ship. It's not like, well, I wrote it, that's QA's problem, they didn't find the bug, not my fault. It's like, no, that's not how this works. That is not how this works. Okay, I think that may have been the last one that I had on it. Yeah, end of PowerPoint deck. So, okay, so I think that was everything I was planning on going through tonight. I realize it's a little different than my usual coding stream, but I got so much feedback on the talk earlier this week. I kind of felt like it was probably going to be something worth having a discussion on and having more videos. Like I said, if people are interested in seeing that hands-on style of thing of, hey, let's look at some tips and tricks for practically writing code for some of the testing situations, let me know, because I'd be happy to do that. Again, I think it's one of those that, in my opinion, that's the easy part of testing, right? Showing somebody like how to write the test, getting somebody in the mental state that they want to start with the test. That's what I've always seen as being the hard part. So, because that's the people problem, not the technical problem. Technical problem, I can solve. That's easy. I can teach you testing frameworks and tools and all of that jazz. That's not a problem. But the mental shift of deciding, okay, I want to write tests. I want to build these out. I think those are the important part for people to get into. Oh, Justin Bieber, no problem. Always happy to. So yeah, like I said, if people like this and want to see some practical application ones, let me know. I may try to con Artem into doing stuff with me. He loves testing as much as I do, so it's usually easy for a nerd snipe. So yeah, Blue Spider, thanks for coming and hanging out. I appreciate all the questions and feedback too. That was great. So I think with that, I'll tell everybody thanks for coming. Happy coding. See everyone next time.